Greetings, my little triglets. Hope everyone is doing well today. All right, we are going to do section 6.3. We're going to talk about double and half angle formulas. These formulas are used a lot in physics and athletics, really anything where something can be thrown in the air or projected into the air. These formulas are used quite extensively in those types of formulas. All right, let's start with our double angle formulas. Double, we have sine of 2 theta. So you can see it's a double angle. That works out to be 2 sine theta cosine theta. Moving on to cosine of 2 theta. The most popular one is cosine squared minus sine squared. There are 2 other versions of that, but we'll get to that in a little bit. And then tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. Now that looks a little like the sum and difference formulas we did, and actually that's where it comes from. If you want to see where all these come from, you can look on page 665 in your book. That just shows the derivation of each of those. But for right now, you can just trust me that those are the correct formulas. All right, let's try a problem here. Let's say that the sine of some angle, theta, is 5/13, and it's in the second quadrant, and I want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Now remember, when I told you before, when they tell you what quadrant it is in, go right to that quadrant and draw a triangle. Don't ask questions, just do it right off the bat. All right, from there, I want to put in y and r. So y is 5, r is 13. That makes x 12, but we're going to the left, so it's negative. So the quadrant is significant because it makes the cosine negative instead of positive in this one. All right, so from here, let's write down sine 2 theta. The formula is 2 sine theta cosine theta. All right, so sine theta they already gave us right here, so I'm going to put that in. Cosine theta, I look over here, I see negative 12 and 13, so negative 12 13ths. And multiplying that through, remember this is 2 over 1, not 2 over 2. So 10 times 12 is negative 120 on the top, 13 is 169. Okay, then the next one, let's do blue. Cosine of 2 theta is cosine squared minus sine squared. All right, cosine squared, we said our cosine was negative 12 13ths, and sine squared is 5 13ths. So squaring each of those, I get 144, and both denominators are going to be 169, so I'm going to combine them right away. And then 5 squared is 25, so together that's 119 over 169. Okay, so let's do tangent. Let me move down here a little bit. We'll do tangent in green. So tangent of 2 theta, the formula is 2 tangent theta over 1 minus 2 tangent theta, 1 minus tangent squared theta. All right, looking at this triangle over here, tangent is opposite over adjacent or y over x. So on the top, I get 2 times y over x. On the bottom, I get 1 minus y over x squared. Okay, so now the rest of this is just simplifying. So, multiplying the top, remember it's 2 over 1, so it's 10 over negative 12. On the bottom, on the right here, I have 144 and 25. The negative gets canceled out because of the square. And then this one, I'm going to turn into 144 over 144. Then I'll have a common denominator. So subtracting those, 144 minus 25 is 119 over 144. Now you can invert and multiply and so on, but what I like to do, I like to get my denominator the same. So I'll have 120 over 144, the negative still out front, and then 119 over 144 for the bottom. So 144's can cancel, and I'm left with 120 over 119. That's for tangent. Now I want you to look at something and notice that sine is negative 120 over 169, and cosine is 119 over 169. And that's exactly, if I put those over each other, the 169s will go away, and I'll be left with 120 over 119. So you don't have to go through all this if you don't want to. Okay, you can, once you find sine and cosine, just go straight to tangent instead of doing the whole formula. Save you a little bit of time. All right, the last thing I want to do is show you the other two forms. Now these forms, three forms of cosine 2 theta, are just for convenience. Okay, the original one is cosine squared minus sine squared. Now, do you all remember that sine squared plus cosine squared equals 1? That's a very, very common, whoa, where'd that come from? Common formula, and we need to memorize it. We need to know it like fast, right now, here and now. If I move things around, let's say I want to subtract sine squared from both sides. So I have cosine squared on the left and 1 minus sine squared on the right. Cosine squared now equals that, so I'm going to replace that with 1 minus sine squared. And then bring this one down, so I get 1 minus 2 sine squared. So that's another version. Here are two versions. The third one is if I subtract cosine squared from both sides. So I get sine squared equals 1 minus cosine squared. So I'm going to replace that for this, so I get cosine squared minus 1 minus cosine squared. Distribute the negative, I get negative 1 plus cosine squared. And then these two can go together to get 2 cosine squared minus 1. So those are the three versions. This one is nice if you have both sine and cosine already figured out. This one's nice if you only have sine. This one's nice if you only have cosine. But that means memorizing three formulas. So you can always get these other two by doing what I did over here. So I would probably only memorize that one. And when you draw the triangle, it's easy to find sine and cosine both together. Okay. Next is half angle formulas. All right. Half angle. So the sine of a over 2, see I cut the angle in half, is equal to plus or minus square root 1 minus cosine of a over 2. The cosine of the half angle formula is cosine a over 2 plus or minus 1 plus cosine a over 2. And the tangent is just a combination of those two, plus or minus 1 minus cosine a over 1 plus cosine a. Now there are two other tangent formulas. Someone worked it out even farther and said, well, it could be 1 minus cosine a over sine a, or sine a over 1 plus cosine a. Now I'll tell you which one is my favorite right here. Because I don't have any square roots, I don't have to deal with the plus and minus, and there's no pluses in the denominator, because that can be kind of a pain to get rid of that plus sign in the denominator. So if I were to memorize one, I would remember this one. It's simpler, it's faster, and just makes me happier. All right, let's try one problem with this, and then we will be done for the day. Okay, let's do, I want to find the exact, so that tells me I need to use my circle, value of the cosine of 112.5 degrees. Well, that is not one that we memorized on our circle. However, if I take 112.5, come on, 0.5, and multiply it by 2, I get 225. Things are freaking out here a little bit. So 225 is my A, and this is my A over 2. Okay, so it's the angle cut in half. So what I'm trying to find is the cosine of 112.5, but I'm going to use my half angle formula for 225. Okay, I could say this cosine of 225 over 2 instead of 112. So this now is my A. So in this bracket over here, this is A. So I'm going to say cosine of 225, not 112.5, because we don't know that one. We're trying to use angles that we do know and use those in the formula. All right, the other thing that you have to figure out is which one of these is it? Is it plus or is it minus? Well, ask yourself, where is this? What quadrant is that in? Here's 90, here's 180, so 112 is somewhere in here. So it's negative. And what is cosine in the second quadrant? It's negative. So I know that it's going to be a minus. All right, so let's work this out. 225. 225 is right here. It's one of the 45s. And the cosine of that is going to be negative root 2 over 2. In fact, both of them are. But we're only interested in the cosine because that's what our formula wants. So the cosine of 225 is negative root 2 over 2. Okay, so all I did was replace that, and the rest of this is just simplifying. So watch what I do. All right, I still have negative. I am going to turn this 1 into 2 over 2 because then I have a common denominator on the top. So I have 2 plus a negative would just be minus root 2 all over 2. I'm also going to change this 2 to 4 over 2. So it has a denominator of 2. As soon as you have same denominators, you can get rid of them. Okay, I'm going to extend this down to make sure you know that all of that is under the radical. Okay, so I extended, or I crossed off the 2's. So what I have left is 2 minus root 2 over 4, all under the radical. But 4, the square root of 4 is a 2. So I can take that out. Well, I still have a negative here. And just have the top be under the radical, and then the bottom, the 4 is still in the denominator, so we have to keep it down here. So that's what our answer is going to look like. Okay, that is the cosine of 112.5. Okay, so we're using angles that we do know in the formula to find angles that we don't know. And we're using half angles and double angles to do that, to accomplish that. All right, I think that is it. We will talk more in class tomorrow, and there will be a quiz coming up soon, so be ready for that. All right, big heart for today. Trig love. Love Trig, it'll love you back. Ta-ta for now.